While Dart is in its core an object-oriented programming language, that doesn't mean that you're stuck only with that paradigm. In fact, Dart is something called a multi-paradigm language, and functional programming makes your code easier to test and reuse, and also makes it less error-prone. With Dart, it's easy to start introducing practical functional concepts into your code in a reasonable amount, and this way you reap the benefits of functional programming while not confusing others and yourself with how your Dart code is written. Hello, welcome to Reso Coder, where you are getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming in-demand Flutter developers. So in this tutorial, we're going to look at functional programming from the very basic concepts, which probably many of you even intuitively know if you have been programming in Dart, even if you have not been looking specifically into functional programming, but still it's good to go over them. And then we're also going to get to the, let's say, intermediate functional programming concepts which are possible in Dart. And be sure to check out the written tutorial from the link in the video description, where you can find all of the code written in this video and overall go through this lesson at your own pace. So to get started, we're going to look at two approaches to writing code in Dart, which is possible just in native Dart without any additional packages. So here we have an imperative way of writing code and a functional way of writing code. You are most likely all familiar with the imperative because this is what your Hello World app tutorials are teaching you. Basically, just create a for loop which will sum the contents of the list. So we need to create an integer for the sum, where the sum is going to be stored. Then we create a for loop, an iterative variable called I, which we increment, and we simply add the value, the integer, at the place in the list at the index I to the already added to sum. So what are we doing here? Well, we really need to think about what the code needs to be doing, what the computer needs to be doing step by step in order for us to be able to sum the contents of the list. We as programmers, we are really interested only in the end sum, but with imperative programming, we need to also declare this iterative variable, then increment it, worry about when to stop incrementing it, and so on and so forth. So we are really diving deep into the inner workings of the program, which in this case, of course, is fairly simple. It's just a simple for loop. But you can see that if you are in a more complex code base, this kind of only imperative programming mindset is going to limit you and also introduces a lot of ways where bugs can enter into your code. However, with functional programming, the story is different. Here we again have the same list, but this time we are using a functional approach, not imperative, which means that we do not need to create any iterative variable. There is nothing like this here. We just need to call list.fold, which is something like a for loop in the functional realm, which will iterate basically over every single element of the list. And this fold accepts an initial value, which we make to be 0, just like initially sum was 0 here. And then this initial 0 gets added to, because previous is initially 0, and it gets added to 1, then it adds 2, 3, and 4. And just like in the imperative, also in the functional approach, we in the end get the total sum of the individual elements of this list. So notice here that in the functional approach, we do not need to worry about any iteration ourselves, about managing this for loop. It gets basically managed for us. And also, we do not need to create a mutable variable for the sum, but it can be immutable, it can be final. We cannot change this sum later. We cannot increment it because it's final, right? So this makes our code less error prone because we cannot mistakenly somewhere 50 lines later, if we have a long code base, of course, decide to, well, increment sum or change it in any other way. And this is, of course, just a very simple example that perhaps many of you already know intuitively, but this is really the core of functional programming. And it's great that we can very simply use it in Dart. And with this basic knowledge, we can now look at other examples of how functional programming can help you write better Dart code. Let's look at another imperative example. Here, we want to assign character count to strings. Of course, you can call .length on any string, A, B, C, and just call length. And this will give you the character count of that particular string. But for some reason, perhaps we are way too lazy to call length always. We want to have a list that bundles this length information inside of it. So at the start, we just have a basic list of strings, very simple. Dart is awesome. And in the imperative approach, we again need to create a for loop where we are going to be changing and adding to this car counts list. This list is of type record, containing string and integer. Record, of course, is the beloved feature of Dart 3, where you can basically create type-safe Dart objects on the fly. So this simple record object is going to hold string, which is the original string, for example, Dart, and this integer is going to be the length. And so inside of this for loop, we add to this car counts list the unchanged string and then also the string length. So if inside of this main method we call imperative one, or let's just change it to imperative, and also in here we are going to print the car counts list, we see Dart, which is 4 characters long, then is 2 characters long, and awesome, which is 7 characters long. But now let's say that in addition to just creating this character counts list, we also want to filter it where it's going to only contain the character counts for strings longer than 2 characters. So in this imperative approach, we need to go inside of this for loop and write an if statement where we're going to say if the strings at the index of I dot length is greater than 2, and only then we want to add it to the character counts list. Otherwise, we're going to leave it out from that list. So now when we run this code again, we are going to see only Dart and awesome. The is string is left out because of course it's precisely 2 characters long, but we add into this list only the strings which are more than 2 characters long. So what's happening here? If we want to change this code just a tiny bit, we need to go inside of this for loop, inside of this whole function, orient ourselves inside of this inner workings of the code about what the iterative variable for the for loop is called, which in this case is I, and so on and so forth, just to add this simple functionality. Again, here it's very simple. This code is here just for the sake of an example. But you can imagine, and I'm sure if you are a Dart developer for quite some time, you have faced code bases where if you are required to go inside of an already written function, sometimes it makes you pull out your hair because it's just so difficult. Even when there are tests written for everything, still, if you need to understand the whole function first before adding any code to it, and you need to understand the inner workings of it, well, that makes your coding experience not all that fun. But let's look at the functional approach to this. Down here, you can see how we can create the character counts list in a functional manner. First, without the filtering by the length of the string that it needs to be greater than 2. So again, we create a list of strings, Dart is awesome. And then instead of creating a for loop and mutating the character counts empty list one by adding each and every element to it as we go through the for loop, we instead call strings.map. And I'm sure that if you are a Dart developer for any amount of reasonable time, you have already used this, but perhaps you have not thought about it that much. And we are mapping this list of just simple strings to the list of record string bundled with its length. Very simple and easy. So let's now call the functional implementation of this code. And we see that we again print Dart is awesome and the string lengths right next to it. But what if we want to add this filtering to this functional approach as well? It's as simple as before mapping this list of strings, first calling dot where on it, where element dot length is greater than 2. And let's actually rename this element to string. If we run this now, the functional approach will also not print out the is string because it's just precisely 2 characters long. And notice what's happening here. We do not need to go inside of the already existing code, in this case just this for loop for the imperative approach. We don't need to worry about the internal workings of the code which was written previously. We just simply come in and add new functionality on top of the previously written code, but we don't need to go inside of that previously written code. We can just compose functions. You don't need to worry about the inner workings. If you write everything properly, you can just create separate functionalities and sort of add them up together, and you will end up with code that is easier to write and easier to read. Like, tell me that this is not easier to read than this for loop monstrosity. And also, obviously, the functional code is going to be easier to maintain. And now, of course, here we are dealing with your regular list, where, and map functions, which all of you, if you've been programming in Dart for some time, you have used these functions already. This is nothing new. But you can absolutely create your own functions that will work in just the same way. And your whole code base, not just your list operations and map operations, but your whole code base will be able to reap these benefits of functional programming. Moving further, let's now take a look at how you create class hierarchies in object-oriented programming in the usual way, and then also how you can utilize algebraic data types, which is more of the functional programming approach to doing things. And with Dart version 3, this is absolutely simple and possible to do. Now, this code, which I am showing right now, is taken from an official Dart language Medium post, but I have made it into an actual Dart code because over there in that Medium post, it was just total pseudocode which did not even compile remotely, but now it compiles as proper Dart code. So if you're wondering that, hey, I've seen this code, yes, you probably have if you've been reading the official article for when Dart 3 came out. So we have a very simple class hierarchy here. We have an abstract class recipe, which contains the time it takes to finish this recipe, the temperature at which this particular thing which the recipe is making should be baked at, and then the ingredients, which is just a list of simple strings. Then also it has one method, which is a member function, of course, of the class called bake. And if we want to create a concrete implementation of this abstract class recipe, for example, for making a cake, we're going to create class cake, add the proper time, temperature, and ingredients, and then implement the bake method. Of course, this bake method doesn't really do anything. It doesn't return anything. It's just a pseudo implementation, but hey, you can imagine that this kind of works. And then if we want to make cookies, we create another subclass of this abstract recipe, add other ingredients, change the time and temperature, and then provide yet another implementation of the bake method, which also rotates the cookies and does all this crazy stuff of dividing the time and multiplying, whatever it does. It's just simply a different implementation of the bake method than for the cake. This is how you usually write object-oriented code. There is nothing special about it. You've seen this a million times. But let's look at the very same functionality of this class hierarchy implemented in the functional approach using algebraic data types. Here we again have the main class called recipe, which contains the same data, so time, temperature, and list of ingredients, but it's not abstract. This class is sealed, which is again a keyword coming from Dart 3. Notice that we also do not have the bake method in here. We actually don't have any methods inside of the classes at all, neither in this sealed recipe, but we also don't have any methods inside the concrete implementations being cake and cookies. Inside all of the classes, we just hold the data. And the data is the same as in the object-oriented version, exactly the same way to call the superconstructor and everything, but we just don't have any methods in here. Why is that? Well, because we are going to perform all of the operations, all of the logic, totally outside of any class. This is not a method because it's not a member function. This is simply a top-level function, at least in this case. And instead of implementing the different implementations for baking the cake and baking the cookies inside of the respective classes, subclasses, we implement the different functionality inside of this top-level bake function based on switching through this recipe. And in case it's of type cake, we bake the cake the usual way, just as in the object-oriented approach. And in case that we are baking cookies, we again have this different implementation. The end result of the functional approach and of the object-oriented approach is the same. The cake and the cookies are going to be baked in exactly the same way, but the code looks different. And the principles behind writing the code are different. Because here, in the algebraic data types functional approach, we have a hard separation between the data and the operation on that data. The data is held in these classes, and the operation on that data is separate. It's just a simple function. And of course, the Dart 3 features make sure that we are safe here. We, for example, cannot forget to check the case for cookies. If I delete this, we're going to get a red squiggly line saying that Type recipe is not exhaustively matched by the switch cases since it doesn't match cookies, right? We should try adding a cookies case. So if I add it back, we're fine again. This exhaustive switch is a feature of the Dart 3, of course, and it's possible just because of this sealed keyword. Sealed classes need to be contained within one library, for example, within one file, as we are doing here. I cannot be extending this recipe from totally another library, from another file, but only within here. And that's because the Dart compiler can then figure out, for example, this thing, if we are checking for every possible subclass of recipe inside of switch. But what is the main difference here between functional approach and object-oriented approach? Here, this bake function is a clean function. That's a name used often in functional programming for describing functions which depend only on their own parameters, and the only way they output something is through their return type. In this case, we have void, but you can imagine we would have some return type here other than void, but it doesn't really matter in this case. What matters is that this bake function is a closed system. Nothing gets in except through this recipe parameter, and nothing gets out of here except for the return. This makes functions very easy to compose and test because you know precisely what's going on. You don't need to go looking into the source code, especially if you have a complex 50-line function, before you try to test it, just to find out what's going on in there. Everything is contained. However, in the object-oriented approach, the story is different. Here, we are actually, in each and every of these bake method implementations, not using just what is passed into this method. Actually, nothing is even passed into this method. We are using the class members. We don't get them from the parameter list of this method, we get them from the class where this method is contained. Here, it's pretty simple, nothing to really worry about. We are dealing with simple classes. But when you have complex class hierarchies with many members, in some cases, you can end up with an entangled mess that is hard to test. And when you test it, you need to provide a bunch of different mocks and know when exactly to initialize those mocks, when to reset the data inside of those mocks, and all that. Sometimes it can really be a mess. Other times it can be perfect. But sometimes when you need to have a cleaner approach to writing code, using this functional approach where data and operations are separate, and you're dealing with clean functions instead of these unclean methods, getting data from wherever, is beneficial. That is not to say that this object-oriented approach is bad. It's not. But sometimes it's better to have this functional approach. Now that we have looked at all of the things which Dart language by itself provides to us, especially starting from the version 3, in order to write more functional code, let's also take a look at a package called fpdart and precisely on how to do error handling with it and what benefits it provides in that area. So let's first go into our pubspec YAML, and you want to make sure that you have a dependency here on fpdart. Current version is 1.1.0, but this functionality is almost 100% not going to change even in the future versions. Again, all of the code and dependencies are also available in the article, to which you can get from the link in the video description. And let's say that we have an enum grade. Of course, grades, at least in the US, can be A, B, C, D, and F. And we also want to be able to parse a string to a grade. So we create a static parse method inside of this enum, which first will make this grade string to be uppercase, so that whether we pass in just A or an capital A, it's always going to result in the same output of grade A. And if we pass in some gibberish, we are going to throw an argument error, invalid grade, and then provide the gibberish which was inputted. Fairly simple, right? This is just basic error handling, basic Dart. And now in the main function, we try to parse the string A into this grade enum, and then we pass it here to somehow use grade, which currently is not implemented, but let's say that the implementation will be that we print the grade. If we run the code now, we see that the output is grade A as expected. But what happens if we input some gibberish like this? Try to run this now, and oh no, we get this exception has occurred thing and our code crashes and nothing works. That's because we do not have the try catch around this parsing code. And the worst thing is, as of right now, unless we remember manually to add this try catch around this parsing code, we are not going to be notified about the need for this try block by the Dart compiler. We're not going to get any red squiggly lines in our VS Code. There is only one way to find out about this missing try catch block, and that is at runtime when an invalid character sequence is inputted into this parse function. So let's just add on argument error catch E and print out E dot message. So now when we run the code trying to parse this gibberish, everything's going to work, sort of. At least our program will not crash. But we needed to remember this in our own head, and that's not very good, especially if you have large code base. You're just bound to forget about some little thing like this, about an argument error lurking somewhere deep in your code base. A functional programming principle is that if something can fail, we want it to fail at compile time and not at runtime. Using exceptions and this try-catch flow is precisely the opposite of the functional approach, because here everything fails at runtime and not at compile time. So what can we do? Well, we have already added the fp-dart package as a dependency for this project. So let's utilize a class called either from it. If we take a look at either, so let me just write either and go to the implementation, we can see that it's a simple sealed class. Well, at least in its principle, it's simple. Here you can see that it has a bunch of mixins and everything like that, and various methods like fold right, fold left, fold map, and all this craziness, which is very useful for people who want to go deep into this functional programming paradigm. But the perfect thing about Dart is that you can use just a bunch of things from the functional programming paradigm. The rest of the code can stay fully object-oriented. And here in our case, we do not want to worry about any of this useful but still craziness, which is here present in the either type. We just want to fix our error handling very simply. So what can we do? Well, this either class, which is sealed, has two subclasses. Right, you see, right extends either, and then also similarly left, which also extends either. The subclass right inside of either is always used to convey the successful output of a function, and the left subclass of either is always used to convey the error. And we have already seen how to work with sealed classes in this tutorial, but fp-dart and this either type has some helpers to sort of speed up this working with the either type. So first things first, what do we want to do here? Instead of returning directly grade from this parse static method, we want to return either string and grade. As you can see, the left is of type string and the right value, meaning the correct value, is of type grade. Now we're no longer going to be returning just straight up grades, but we need to, of course, wrap them up in either. But not just directly in either, of course, but in one of the subclasses. So we want to wrap it in right, and this right constructor accepts a value of type grade. So it's going to be grade A. And this would work, but actually the usual way to work with either is not to call the constructor here, but instead a helper method, which is the lowercase r for right. And this is the usual way you're going to see the code written with either. But as you can see, if we look at its implementation, this helper instantiates the right subclass of either. So let's do that for all of the other grades as well, like this. And now we no longer want to throw an argument error, but instead we want to return left containing this invalid grade string. So what have we done here? Well, we have just unified the correct output with the error output for this parse method. Now there are no longer two data flows for the exceptions, which we need to use the try-catch blocks for, and for the correct output value. Everything is unified into just this return type. And this is awesome because now we of course can remove this try-catch, but now we can no longer possibly forget about checking for this error, because grade.parse doesn't return us grade, but instead an either of string and grade, and we just cannot pass this directly into the somehow use grade function, which expects just pure grade. We get an error saying the argument either cannot be assigned to the parameter type grade. That's true. And in order to get to the actual grade which we want to pass in here, we need to use our trusted switch, the exhaustive switch, which works again because either is a sealed class, as you can see here. Let's actually rename this grade to grade either. And now we want to switch on this grade either. And in case it's left, which is just the regular name for the left subclass of either, the value inside of this left subclass, we're going to assign it to final L. And what do we want to do here? Well, we somehow want to handle the error. So let's just say print L. And in case, which we again need to check because we are inside an exhaustive switch, which currently is not exhaustively matched. So to match it exhaustively, we say case right, and the value of right, which is of type grade, will be passed into final R for right. We're now going to somehow use grade, which in this case, grade is this R. Awesome. So now when we run this code, it again says invalid grade. Makes sense. If we pass in a valid grade, let's say C, we're going to see grade.c. But as opposed to the usual error handling, now we are forced by the compiler to actually really handle the error. We cannot just simply forget about it somehow. It's impossible to forget about error handling when you're doing it in this way using a sealed class, in this case the either sealed class. But of course the fpdart package, being fpdart, has a simplification for this either type, which we can use instead of this switch statement, which of course switch is pretty simple itself, but we can simplify it even more. So instead of writing this code, we instead can write great either dot match, and here for the left value L, we want to print L. For the right value R, we want to somehow use great and pass in R. And as you can see, this is shorter than the switch statement, but it does exactly the same thing. So we can now delete the switch statement and run the code, and it's going to work in exactly the same way. So now we have gone through the basics of practical functional programming in Dart, and also how to use it in your own apps. Especially this either type is very, very useful. We have not looked a lot into the fp-dart package, and there is much more to it than this either type. So in the future, I would like to create a tutorial focusing more on the fp-dart package itself, now that these basics of functional programming are out of the way. So if you do not want to miss that next tutorial, which is incoming, you really should subscribe to this channel and also hit the notification bell so that you will be notified about when that tutorial comes out. And also to go through this tutorial at your own pace once again, and to get all of the code we have written here, check out the written tutorial available from the link in the description. So if this video helped you, give it a like, keep an eye out for the upcoming tutorial, so make sure you are subscribed, and see you in the next video.